So we have different layers. These are gonna be the different layers of pedals. Obviously, you go from 2-inch diameter, 2.5, 3, 3.5, 4, 4.55. Now we just gotta draw the pedals. So right now we just have them taped on here, outlined. We're cutting it out roughly with the foot of the bandsaw, then we're gonna grind it all down, get smooth edges, and then sand everything down, make it not sharp. We got a rough cut of all these pieces, and now we add a grind around the edges, make them all smooth. Not smooth, but get them in a shape. Then when we get them in shape, then we can smooth them up.
We have the rough shape of all of them. Now we are going to on the belt sander.
Alright, so we have all these grinded down right into the shape. Now we have to texture this to make it look like a stem. So I'm gonna heat it up, hammer it down, so it starts looking less like a rod and more like a stem. So, yeah. Alright, this is what the rod looks like now. It looks closer to a stem than before. Got this, got that. I need to make some holes, clean all this up, start tacking and bending it and shit. So right now we have the stem, and we have that first little pedal. When I was welding it, I accidentally melted through the stem, so I had to try and rejoin it, kinda. So it's a bit ugly, but it'll be hidden by the pedals. Speaking of pedals, we have to grind these down, get all the rust off them, just make them clean, shiny, before we start stacking and bending them. I forgot to start recording when I started, but we have them all shined up and stuff now. Right now we're just stacking them and tacking them, and then tomorrow, when we have the time, we're gonna heat them up and we're gonna start bending the pedals into shape.
Alright, so right now this is what it looks like. Tomorrow I'm going to heat up the pedals and bend them so it looks more like a rose than this. And we're going to hope that it turns out good, so yeah. Alright, the rose is now done. The pedals, got some thorns on the side there. They're pretty sharp. I probably shouldn't have made them as sharp as I did, but I wanted to be pokey like a thorn. Yeah, that's how you make a rose. We need 2 3-inch pieces for the CWB, so here's one of them. And there we go. We have 2 pieces now. Now we gotta bevel the other side. I'll show you. Okay, so we have this torch set on a 30-degree angle, and we have our metal preheated. So we're gonna swap the direction. Hold this here until that metal gets red enough where it's at the kindling point, and we can start adding our oxygen to initiate the cut. Which is about right now. Then turn on the track, and it starts going. And as it pushes away from me, I can see on the inside of the kerf, I can see if there's any abnormalities, you know, anything like that I'd want to restart the cut and try again. Let's check it out. And it looks pretty good, so we're going to keep that. The edge is nice and cleaned up. It's going to the back-end bar right here. It's going to provide, this being grinded down, it's going to provide us with better penetration, as you want to penetrate that mill scale, and just better overall fusion. So right now we have this all printed up and ready. We have the vacuum bar set, 2 pieces, the inside's nice and grinded. We have a 1/2-inch gap between plates, which is regulation, and conveniently enough, a piece of soapstone is exactly 1/2 inch. So usually just use that to separate the plates. So I was going to tack it up, get everything in place, and I can start welding it out.
All right, Nico. So a little bit of spatter here. I'd knock a little bit of spatter off. Your grind marks. I don't like your grind marks going across the grain. You want to have your grind marks going with the coupon and with the weldment. So your grind mark should have been going lengthways. Other than that, it's not too bad. Pretty tight gaps on there. However, little tiny bit of a gap on the square side. That's okay, it'll fuse in there. Hopefully we don't get any slag entrapment in there. Once you knock that spatter off, you will be good to weld. What I'm going to do is I'm going to get you to weld from the outside of your coupon here. Using that waster plate, you're going to let it heat up, and what you're going to do is let it fuse in. You're going to weld from, give me a weld from here to the 1.5 inch, no, sorry, to the 4.5 inch mark right here. So I want you to weld from here to the 4.5 inch mark on this end here. That'll be 1.5 inches down here, as these are 6-inch plates. You're going to weld from here to here. Okay, once you do that, bring it to me and I will double check it. Make sure you're only putting in a 5/16 maximum size bead in here. Okay, that's the max size. If it's undersized a little bit, it won't be the end of the world. But if it's over that 5/16 threshold, it'll be an automatic fail.
I only do 1/4 inch beads, Bruce.
Nicely done. All right, so we'll take a look at this here. Not bad. I would have used the waster plate a little bit more than you did, just to have it heat up enough. You can see with the narrower bead here, it just got hot enough that you're just starting to make a thicker bead. And your bead in here is actually pretty nice. Pretty good bead. Got a little tiny dot of spatter there. If you can chip it out, do. If not, you're going to burn over top of it on the next pass. That's totally fine. You stop right at that 1.5 inch mark. That's good. You're going to have to give me a Z stamp. Give me a Z stamp somewhere in the middle of the coupon that lines up right exactly with the very end of the crater. Okay. Your bead itself, you're looking at a 3/16 to 1/4 inch fillet. You're well under the recommended 5/16, which is good. And go ahead now and give me the bead from here. Start a little bit further out than you did, just so it warms up nice, and get a bead on that beveled edge for me right up until the 1.5 inch mark. Nicely done, Nico. All right, so here we go, back at it. You got the first pass, second pass, very nicely done. Still have that little bit of spatter. We don't really have to worry about that too much. You have some really nice overlap here. This is where really what we like to see, where the bead lays right over top of that other bead in the middle. You don't have a gap in between the two, which is nice. If you have a gap in between the two, you'll end up with slag inclusion in there. You've done a great job cleaning this one up. I don't see any really big pinholes in either on the ends of the welds at all. I think this is going to end up great. Go ahead and give me the Z stamp on the bevel side. And then let's have you finish off pass number 1, and then come show me after finishing off pass number 1. All right, very nice job here, Nico. Looks like you kept it under that 5/16, and we can tell, the reason we can tell it's under 5/16 is because the plate itself is 3/8 thick. So you can tell that's under 5/16, and you put in a good bead there. Nice start stop, a little bit more bulbous, which is good. We'd prefer that than having a little bit more than less, because it makes for a good start stop and it's nice and solid. You're good to put that other bead up this other side and come show me when you're done. So here we are. That's pretty good. Now you ended up pretty good start stop here. You went fairly slow, got it running, and then when you left the start stop, you sped up and you ended up with a little bit of a void here. It can cause a little bit of slag inclusion. So if it's going to tear open, this is where it's going to tear open. Decent looking bead. Looks like you're well within that 5/16 range as well. And looks to me like you're going to be able to fill this one up. Go fill it up and then show me after you're done welding it up. We'll talk about capping it when you get it flush. When you get it close to flush or near flush, we'll talk about capping it out before you actually cap it out.
All right.
Okay, so it looks like you have a little bit of a low spot here, just in the middle. But I think you're good to cap it for the most part. It's a little bit cool from overnight. So what you're going to do is you're going to preheat it. We'll get it heated up just enough that you wouldn't want to leave your hand on it. And then I would like to say that you're good to go. All right, so this is the final result here. This is a really good weld. Almost wanted a valley on you. But you could have slowed down ever so slightly to build that up a little bit more. Almost a low spot right here, I've noticed, but I think that is still going to be over flush. So I think we're going to call this one good. You have really nice orientation with the beads. They all seem to be really well aligned. You're getting to the halfway point of either bead for the most part, other than the one little valley spot. Yeah, I think you're pretty safe to go chop this one up. We'll turn it into coupons for bending.
Okay, now that we have our CWB test plate completely welded out, we are going to gouge off this back plate with this oxy fuel torch, and we're going to set it up right here, this holster for it. And then we're just gonna turn on the flame, heat it up, and just run across it. All right, so we have our torch, and we have fire now.
What kind of gas is that, Nico?
This is oxyacetylene, right? And for this, we kind of want a bit more of a carburizing flame as compared to a neutral one.
And
So,
what's the difference between carburizing and
crank
neutral?
up. Sorry?
What's the difference?
More acetylene than oxygen. We get pretty high up. We keep it more on the carbureting side. So about right there should be good. And now we'll start preheating. Now that we have this nice and red hot, we're at the kindling point, and we can start gouging off the backing plate, and we're going to do so in smooth, consistent moving motion, like so. Yeah, so that's one pass. You can see we got like a third of it off already. We're just gonna keep doing that until we no longer have this and we're just remaining with this. Now that we have gouged off our backing plate, we're gonna mark this up into 3 coupons. One of them will be testing the face, one of them will be testing the root, and the other one will also be testing the root. We have this handy little tool here that allows us to mark these up pretty easily. Pretty fortunate to have something like this at the college. Just makes this a lot easier. Now we're gonna grab a square, straighten up. Alright, now we start marking these up. Get these lined up. Now we're gonna save these 3 over here. Alright, so right now we're in the grinding room. We need to remove all of the slag off the side of these coupons. And after we remove the slag from the sides, we will chamfer. Since this is a face bend, we will grind down the face until flush and leave a little bit of material on the root just so we know where the weld is and where to bend. So I'll come back when these are done. Alright, as you can see, we have grinded off all of the slag off of our coupon. We left a little wagon track on the back where the root is so that the inspector knows where to center the coupon. Our face is completely ground off, and as you can notice, the grain of the metal is going in the same direction as the coupon, and this will assist with the bending of the coupon and will prevent possible breakage. The last step that we're going to cover before bending is we're going to take this over to the belt sander, we're going to clean it up and polish it, make sure that the grain's going in the way that we want it to. Now that I'm here at the belt sander, I have my piece in my vice grip, my hand blade and belt, and we're going to clean this thing up. It's important that you know when using the belt sander, you want to stand in that leaded position so that you're not thrown off guard by anything, and you want to move along with it smoothly like this. It looks a bit stupid, it's the safest way to do it. Now we have this coupon fully cleaned up, grain going in the correct direction. Our back, I messed up a little bit, grinding the side here a bit too much. You can still tell where the weld is, so we're fine. Side, grain going in the correct direction, everything's cleaned up. This is what your inspector wants to see.
Alright, so we're going to lube this up. Lube it up before we stick it in. Before we put the coupons in the bender. Going to make sure that we're bending in the right way where he's left me wagon tracks. He's got wagon tracks on these two, so I know that those are going to be root bends. But I can also tell the root bends by being able to find the Z stamp, and the double Z stamp. So I know that the double Z stamp is going to land on his bevel side, and his single Z is going to be, that's going to be his square side. We're going to put these in the bender, we're going to slap them in the Dream Crusher and see what happens. I always do the roots first. Nico, you got your fingers crossed?
Underneath them crossed.
Oh, that's showing some confidence. Hopefully not overconfidence. That? Yeah, looks like you got it. Little tiny bit of discrepancy here, but nothing to write home about. You have 1/8 tear per coupon. You're good to go there. Next one looks pretty good as well. More difficult ones to pass, but I think you blew it out of the water.
Oh, now we got the face bend.
Little tiny dot of porosity in the middle of the start-stop, but it's got to tear open more than 1/8 to even come close to a fail. This one here, notice how it's nice and flush on the front. Should be wagon tracks on the back, so it's not bad.
I messed up the side right there.
Took out a little bit too much, but that's all right. We won't hold it against you. Your coupons are a nice 3/8 to 5/16. 5/16 is the minimum we can accept for the thickness, and you're well above that threshold. You're good to go. So I'm going to bend your face. Put this one in upside down. Might even lube it up one more time before you stick it in. Putting the face in there. The beauty of having the wagon track, I can tell where exactly middle is putting the coupons in the bender. Third one. Well, Nico, it looks like you kicked some ass and got yourself a pass. Woo! Nicely done. All three of them together. Root, and face. Easy pass.
That's how you weld a CWB, guys.